All right, everybody, welcome back to another Ask a Dev Unreal Engine live tutorial. We have just the right amount of crazy to try to do these things live. Something always goes fun. I don't expect today to be any different. Welcome to the stream, Ethan, Alex. I can see you. Your name always confuses me. I think you're telling me the stream is working when I read that. Off the Rails PBM, Caesar. Good to see you all again. Good to have you all back. Dude, exciting day overall. The 5.4 preview just came out. For those of you that missed it, a couple quick announcements. Sanal tipped me off this morning about it. Working on installing. There's a lot of really cool stuff with control rig, complete. There's a bunch of new stuff for animation, skinning. We'll do some videos on key features based on y'all's requests for those. But today we are. Oh yeah, I should probably mention. My name's Kevin, y'all. I currently work as a senior principal tech artist. Super pretentious title. It just means I'm stumbling through this with all you all, just as much as you all. Unreal is a super deep thing, super deep program. You all being part of this community is awesome. I learn a ton from you, from your questions, and I very much appreciate you all being here and showing your support for the channel. As always, if there are any super chats or stickers, I'll hang out and answer questions at the end. Today we are going to be talking about a different way to do corrective stuff. We're going to be using spherical readers and control rig to set it up. This is great for things like accessories and quick little one-offs, where you don't want to actually have to go in and do all the pose assets and the exporting and setting it up in Maya. So with that, let's go ahead and get started. Looks like all our volumes and stuff are working. That's good. Here we go. So before we get going, a quick little tour of what we're going to be working with. So this is a Mani that I exported from Unreal and I put into accessories. We have a little knife loop on the hip and a pauldron on the shoulder. And we're going to be using control rig to set it up so that these things will automatically fix themselves and not collide while we're working with it. So that's the setup. The important thing to note from here, as far as things note, is your joint placement. You want to think about, right, where this thing is and also how it's oriented. So you'll notice that even though this pauldron's on the shoulder, I have X down the length of the axis. I'm doing that strategically because I want to be able to rotate it from this pivot point. And the same thing with the knife. I've got the same thing down here on the hip. And this can be any accessory. It could be a pouch. It could be a piece of cloth armor, something, whatever you want. Same thing here. It just pivots from the handle. Those two joints are put in. We then take this and we export it as an FBX file. All right, and then we import that into Unreal. So if we go back into Unreal, one of the things that I want to show you when we look at this in Unreal, that is on the wrong screen. Give me 1 second. Okay, so all I've done in here is I have taken, I've made the knife blatantly obvious to see, and the pauldron I added some of the textures from the, I just blanked on the name of what project that was, but it was a free one that came with Unreal. And the big thing that I want to show you though is in the skeleton. So you'll notice that even though this is a prop Mani, like I've called this prop Mani just for testing, you'll notice in the folder I have my skeletal mesh, which is normal, but I have a new skeleton. All right, I did not import this as part of the base skeleton. I imported it as a new skeleton. I've been doing this a lot lately because it helps with skeleton bloat and things like that. And so what I did in here as part of the setup in order to get this character to work with all the animations that have already been done with Mani is if you choose Window, Asset Details, I have added the Mani skeleton as a compatible skeleton. By doing this, it basically tells Unreal that this is the same skeleton, it's compatible, it just happens to have some extra joints. Now the key here is the joints for the pauldron, the knife, or any of your accessories, they need to be leaf joints. That means you cannot change the hierarchy that already exists. It needs to be something that hangs off the end of an already existing joint. So in this particular case, you'll notice that I actually named them wrong. So bear with naming while we're doing this today. But this prop is called pelvis left prop A. but it's parented to the pelvis, and it doesn't change any of the existing names that were in the hierarchy, and it doesn't change any of the order of the hierarchy. And the shoulder one, unfortunately, I did not name correctly, and it is actually called, that's the right side. Hold on, where's the left side? Here it is. It's actually also called pelvis left prop A1, and that's just because in my speed of trying to set this all up, and that one's up here. So it is important to note that this is also just parented in, and it's just it basically is a separate leaf bone off the hierarchy. Everybody with me so far? USB master. Yeah, no problem. I did what you stated. Wait, hold on a second. I did not get a chance to watch State of Unreal. Nope, but I've been going through all of the stuff that's new in 5.4 though. We were talking about that earlier, so. Okay, so this is our setup. Our character's good to go. Now, how do we know this works? If we go back into our third-person character, because this is what we're going to be testing it on our blueprints, all you have to do now is substitute in your new skeleton, and then when you run around on the level, you'll notice that we have our propped character, which is cool. Okay. Now let's get into how do we drive these new props using Control Rig. So if we go back to our mesh folder, what I'm going to do is we're going to create a new Control Rig. We do that by right-clicking on the skeletal mesh, choosing Create, and then we're going to choose Control Rig, and I'm going to call this the prop Control Rig Live for clarity, just so I know I'm working on the right one. And when we open this up, if any part of this goes a little fast, don't worry, there's an entire series of Control Rig stuff that's out there. But what I want to do is I'm going to set up 2 simple controls so I can test our correctives. All right, and I need one for the upper arm. So I'm just going to click the upper arm down here. Let me make sure you all can see this. Where the heck is my screen? Okay, you should be able to see this. All right, so I'm gonna right click. Oh, you know what? Let's go ahead and do this too. Let's make this a little easier for you all to read. Okay, so over here on the left, I'm gonna right click on this arm, the upper arm. I'm gonna choose new, hold up a second. New add controls for selected. Okay, and that's going to create a control, and I'm going to do the same thing down here for the left thigh. I'm going to pick the thigh, I'm going to choose right click, new, add controls for selected. That is going to drop 2 controls in for me very quickly. Over here on the right, I'm just going to change these to circle thicks. I'm going to rotate them 90 degrees, and I'm going to increase their scales to 3. And you should see them show up here in the viewport. So you see we have 2 red circles. Okay, and very simply, all we're going to do is connect these so I can use these to test. So let's start with the thigh. I'm going to get the control, and I'm going to use this control to set the bone transform for my thigh. When I connect these 2 in, what happens is, when I compile this, you'll notice that if I take the thigh control and I rotate it, you'll notice that my dagger or knife, my throwing knife, does not move. This is what I need, this is what I want to be able to test our spherical pose readers, which is where we're going with all this. All right, so we're set up to do the thigh. Let's go ahead and hop into the spherical pose reader. This is really cool, and this is kind of why we're here today. Let's see here. Just make this a little bigger so you all will be able to see what's going on. So here's what we're going to do. We're going to drag off here, and we're going to type sphere, and you'll see there's a spherical pose reader that pops up. When we drop this in, the way this works is it's probably better when visualized, but we need to give it which bone this pose reader is going to work with. And in this case, when we move the thigh bone, we want the knife to update. So that is going to be the bone that we're using to drive this. The minute I connect that, I connect the bone, you'll notice this spherical shape that looks like a little bit like an eyeball right now shows up. Now, the other thing that you'll notice is there is a red line. Let me show you the red line. You see this red line that is sticking up out of the control? That is the current direction of the vector that is being used to drive this pose reader. So when I rotate you'll notice that the red line moves as well. You with me? All right, let's bring back our mesh so we can see that. Now there's a couple things we want to do. What we want to happen, or the way this works is, as this red line dials in to the spherical region, you'll notice that it lights up yellow. Once it hits that, that's when this spherical pose reader is active. And it basically from the edge here where it turns yellow all the way to where it turns green, that is the blend in phase. And once you hit the green region, it is fully active. It means you've hit the target. So anywhere in the green region, this thing is going to basically output a value of 1. Anything in the yellow region is going to be somewhere between 0 and 1. That's the way this thing works. Okay, and that's cool because we can use that to drive rotations. So let me bring back our chat. Okay, cool. So one of the things that I want to do first off is I need to move this because we want the dagger to move when we go this direction. All right. So what we're going to do is over here on our driver axis, actually not our driver axis, our rotation offset. Right now we have 90, that puts it in front. If we put it at 0, you'll notice it moves to the other side. So we actually want 180 for this case. So 180 is pretty good. Actually, it's probably a little less than that. Let's try 160, 170, 160. I like 165. Let's go into 165. Okay, so 165 looks like it's good. Now our axis is kind of pointing the wrong way. So let's go ahead and flip that. We're going to change this to a -1. Notice how the pointer now points down the length of the knee, and as this rotates up, it'll start to light up yellow and the green. But we want to make the region bigger because the knife is already going through the character's thigh long before we get to 90 degrees. So we need the knife to kind of kick in. Basically, we need this to kick in almost right away. And we control that with our fall off size. So if we set our fall off size to 0.5, you'll notice, see how much bigger this gets? That might be a little bit too much. Let's try 0.4. That looks pretty good. Okay, so 0.45, right about there. So the minute this, we may want it even, actually we may want the 0.5. Let's see what 0.5 looks like. That's pretty good, actually. That's pretty spot on. Right when the leg starts moving, we're going to want this thing to dial in. Now, as we dial this in, what this is going to do is this is going to output a value 0 to 1. So what we want to do is we want to drive the joint, that is the rotations of the joint that is our dagger, based on these outputs. So here's what we're going to do. We are going to find our joint for the dagger, which is somewhere, here it is, and we're going to set the rotation. And the easiest way to visualize this is if we take this value, if we move this up here, I am going to create a from Euler, and I am going to plug in a value to our rotations. Okay, now you'll notice the dagger flips out. See how the dagger flipped out? That's because this is currently in global space. I'm going to use local space. All right, but there's a trick. The local space rotations of this thing do not start at 0. Okay, they start at some value. So what I want to do is I need to get the rotations first and add to them. So let's go ahead and do that. So for this thing, let's get the bone. We're going to, from the transform, we're going to take the rotations and we're going to say to Euler, and we're going to take those and we are going to add a value. Nope, not an array. Make sure you get the right add. And I'm going to actually plug this into the second pen and disconnect the first one. Okay, so rather than going from 0, what we're going to do is we're going to go from here. Okay, so we have our pelvis initial is what we want in local space, and you'll notice that now it's sitting down here still through the knee. Okay, so we're taking our initial rotations of our dagger bone in local space. Okay, we're taking those and we're adding currently 0 to them. And we're taking those 0 values and we're setting the rotation of the dagger. So right now we're not adding anything. Okay, but look what happens when we add something here. Let's go ahead and type in a -90 and see. No, that's 80. Let's try 90. Okay, look at where our dagger is right now. That's pretty good. Okay, so what we want is we want this rotation to be driven as our leg rotates into position. Now we're also going to have to update the translation a little bit. I'll get to that in a second. But for now, let's just go ahead and do that. All right, and now, what did I say we have to do? We have to connect in the weight value. This pose reader is outputting something between 0 and 1. So the weight of this is going to be driven by where our pose reader is. Now you can see that our pose reader already is working. So as we pull out, you can see as we rotate our leg down, this is now automatically rotating into place. This is cool. All right. So we can take, for example, an extreme case, and we also do need to do some translation to kind of move it up, and we can do both. So rather than setting the rotation of this bone, let's go ahead and set the transform. Set the bone transform entirely. So let's connect this in. We're going to, so I just switched this to set bone transform. We're going to connect this in. We're going to make sure this is local space. We're going to break this open. I'm going to connect in my rotation. And then what I want to do is I want to get the initial translation, and I want to add to that as well. And what we're going to add to that is we're going to add whatever value we need to kind of offset this. So let's just go ahead and plug this in. And we are going to have to play a little bit with the values here. So, or I could just cheat and look at my notes. For time's sake, let's just do that. Let's try a -5 and maybe a 10, 5. Sure. Okay, so here's what's happening. We're getting the initial bone value. Then we're adding to it a rotation and a translation to offset it based on where, and we're going to drive that based on how the thigh is currently being rotated. So when we rotate our thigh control, we forgot to connect in our weight. That's important. Okay, so as we rotate our thigh control, you'll see that this kind of blends up and off the character's leg. That's it. That is how we can use these spherical pose readers to drive additional animation and use these for correctives. So with that, this is all connected now. It's ready to go. Now what we can do though is we can take this and we can connect it into our Anim blueprint, and we'll do that here in a second. But before we do, we have enough time. We're going to go ahead and do the correctives on the shoulder as well, because there's something a little bit more interesting about that, because you're dealing with multi-axis for something like the pauldron. Okay. All right. Yes, USB, the motion matching system has been in there for a while, and I'm very excited to start to play with that. Okay, so doing this exact same logic and idea, there's one little caveat. So let's just take this whole network and let's copy it, I think is what we're going to do. Yeah, okay. Okay, so this is let's comment this. This is going to be the knife, or let's call this the pelvis props. And then over here, we're going to be doing the shoulder. So first, let's just get the shoulder working. One thing we need is right now when we rotate our shoulder control, it does nothing. We need to connect it in. So same thing we did before. Let's take this up arm control. Let's get the control. We're going to use the value, and we are going to set the left up arm. Set the translation, not the translation. I'm going to set the bone. Connect this in, and then transform value, compile. All right, so now we have a control that we can use to modify our shoulder for testing purposes. We're gonna take all these out when we're done because the rig's gonna drive them. I'll show you what happens if you don't. It's actually pretty fun to look at. So now we have our test, and now we just need to connect it up. So the bone that we're going to be driving this time, if you recall, I accidentally named it wrong in my rush to get all this stuff ready, but trust me, it's the shoulder. This is the bone we're going to, oh, actually, no, the bone we want is the up arm. That's escape, up arm. Okay, and what we're driving in this case is the shoulder accessory. Okay, and the rotations are going to be coming from, okay, so we're basically getting, once again, we are getting the original, are you kidding? All right, let's restart. Yay, crash. Give me 1 second, y'all. I should have compiled and saved. I forgot to save. That's okay. We'll get back on track quick. All right. So let's see here. This is the live. Yep, we did not have a whole bunch of saves going on, so we're going to shortcut this a little bit. Let's take my notes and we will just copy to get back to where we were. I always do that. Unfortunately, I am going to have to remake the controls. Comment, pelvis, corrective. I'm actually going to skip making the control for the leg again. I think you all understood how that worked. The upper arm, though, we do need new control for selected. Down at the bottom, grab that, make that a circle thick again. Rotate it 90 in Y, 3 in scale. So now we can see it. Let's get the control. Let's set the bone. Set the bone, translation, etc. All right, compile and save. Let's make sure we're back to where we were. We are. Fantastic. Okay, so this time we're not going to copy paste. I guess Unreal did not like that. So let's compile and save this. And we're just going to drag out another spherical reader, and we'll just do this manually. Spherical Pose Reader. The bone that we're using, once again, is our left up arm. You'll see that this shows up. That's great. But we need to place it a little bit differently for the shoulder. So where we're going to place this for the shoulder is we are going to try. All right, so our axis is down. It looks like our axis is correct on this one. So it's pointing down the joint. That's great. So let's take a look at our rotation offset. Let's zero this out. That's pretty good. Let's go 20, not 50. Let's try 20 here. Okay, that's a good spot. Now I want this to trigger. It's interesting, when they created the models for these pauldrons for the Infinity, I think it was Infinity Blade maybe. They modeled these way up off the shoulders, I think specifically so they didn't have to deal with all the penetrations. But because of this, we can deal with the penetration pretty easily. So let's see here. I'm going to reduce the, actually no, not yet. Let's go ahead and go with fall off size of 0.35 on this one. And I want to show you something a little bit different. Okay. On this one, we are going to change the fall off region scale factors. And I want you to watch what happens to the shape of this sphere when I change this. If I go 1.4 on this, do you see how this kind of bends down? It's extending it out. It's extending it out so that, as in this case, as my arm rotates up, it'll touch this edge a little faster. So you can kind of warp the edges of these things by, in both the active region and the fall off region, using these positive negative width scale multipliers. So this is just a value that I found in this particular case that worked well. And then what we're going to do, compile and save this, what we're going to do with this is we are going to do the same thing we did before. We're going to get the bones, initials, the translations, etc., and let's connect them in. In this case, the bone that we're going to get is going to be our prop A for the shoulder, making sure we're getting the local space, and then we are going to set the bone just like we did before. Oh, you know what? I didn't redo this. Let me redo this so you all can see this after the crash. Okay, cool. So we're going to set this, and our rotations, we'll start with 0 for our rotations, and we do need to go from Euler and plug that in. Okay, and then we'll go translations. We're going to need these to be 0. Okay, so we're getting the initial translation of prop A. We're basically taking that, we're adding, should be adding 0 to it, setting that, and we need to make sure that this is set to local space. All right, compile and save. Okay, so now what we need to do is we need to mess with the values. In this particular case, as we rotate up into the region and we activate it, we want this pauldron to rotate, and it's also going to need to translate a little bit as well. So let's go ahead and do that. And we're going to try, let's try a -80. In this case, I'm going to cheat. Okay, so that's pretty far up there. Now, part of the reason for that is our activation region's a little bit big. So what we can do is we can change our active region size, and I'm going to cut that in half. 0.05. No, 0.05. There we go, that's smaller. But we haven't actually connected in our output parameter to our weight. I missed. Here we go. Okay. So as our arm rotates up, this starts to move. That's a little bit sensitive. I think we can update that. Fall off size, that looks good. We're going to change that a little bit. Our driver axis is okay. Let's try changing our translation values a little bit. Did it just get dark in here? Hold on. All right, well, we got mood lighting today, y'all. So, okay, so let's see here, 6. I think that's better placement. So now we can drive this pauldron, okay? Now, this is where it gets tricky. So far, we've just done the same thing that we did with the hip. The problem is that as we rotate this forward, it does nothing. So, and also as we go down, it does nothing. Wouldn't it be cool if there was a way for us to handle each of these other axes as well? And there is, roughly speaking. So one of the things that we can do is we can add a couple other pose readers and interpolate between them. So let's go ahead and do that. So what I'm going to do is I'm going to add a pose reader, and we are going to try to copy paste this time. Okay, and this pose reader we're going to put in front. And the way we're going to do that is we're going to take our 90 offset, and we're going to go 0. So now we have a pose reader that's in the front and one that's on top. we need to make a couple of adjustments in this. We'll go ahead and go 1 on this, and then negative height of 1.5. Interesting. I don't know if we need that one. We might. Let's see if we're gonna like that. But these are the settings that I had that worked. Fall off size 0.5. That is a big region. Okay, well we can doctor that in a bit. I don't think we actually need that much. We'll just try this 0.1. Kind of so that it covers the front half. So now this pose reader that's in front, this one activates as we come forward. Just like we were doing before. And we may want to make this activation zone a little bit bigger in this case. Let's see. We'll try something a little bit bigger. All right, and then we just need to connect in. We need to take this output param and we need to connect into an additional set of translations. Now this is where things get a little bit different than what we've set up so far. Right now we're setting our bone. We cannot set our bone again because I would override, right? What we need to do is we need to blend all this stuff together. So to do that, what we're going to do is we are going to throw some interpolations in here. So let's walk through this. Let's go and let's put in an interp. Now, when we have nothing, we want to start with our base case. So the first interpolation that we're going to do is we're going to interpolate between our default, this is our default rotations, okay, and our first set of rotations on this first pose reader. So that is this one here. And that blend is going to be driven by our first pose reader. I'm going to take out the setting of this transform right now, and we're going to move this down the chain. This is going to get moved way down here. And in a minute, we're going to reconnect this. All right, so that's the first one, that's the shoulder up. All right, then we need another interpolation. This interpolation is going to be driven by our second pose reader, and it's going to interpolate between the first one and our new one. And our new one is going to be a similar thing. We're going to take all of our bones, initial values, etc. from Euler, copy and paste, compile and save. Now this one, the values are a little bit different, and we can isolate it in a second, but we're going to blend into here. This is going to be interpolate, and this interpolation is going to plug into our rotation, and then that is going to get to be our final joint position. Now we're going to need to do the exact same thing for translation. So to be clear, this is the rotation when the arm is rotating up, sideways basically. This is going to be the rotation and the spherical reader when the arm is forward. This is going to interpolate between no adjustments and the arm up adjustment. This is going to take the total interpolation so far, feed it into our arm forward, and interpolate between those two. And we're going to adjust our values here. We're going to go with, let's go with 0 here and 60 here. And you basically just play with these values until you find something that you like. And this is going to be 0 and -5. Now, if you're having troubles, it might be easiest to isolate this, like skip one of these and just feed in straight to your final just to see what else is happening. So if we compile this, I'm going to save it just to see where we are right now. When we blend up, we still have our upward blend. That's cool. That's still working. That feels good. Do we have forward? We have no forward blend because hold on a second. This is our spherical reader. It is feeding our output. This is our pelvis prop A. Ah, these aren't connected. That's our translations though. Hold on, I'm missing an add. Interesting. hold on a second. This interpolate feeds into here, and then we're adding the value. Of 60. Okay, let's troubleshoot this, y'all. We're going to skip our upper arm. Our drive axis is correct. Our highlight is green. Let's do something real quick. Let's put a print in here. I want to make sure that this thing is printing it. This is actually a value. It's currently set to 1, so we know that's working. So that's not the problem. Let's compile that. Okay, and then our rotations, we're getting the default local space of prop 1A. We're taking and we're adding to that a value of 60, and from that we're feeding this into here, and we should be interpolating to that. Let's try some different values. I don't believe it. Something is suspect. Let's just connect this in. Oh, duh. Okay, so our weight is the problem. Our weight just needs to be 1 all the time. Okay, because we're basically blending between nothing, and each of these are going to be interpreting appropriately. So let's go 0 and 60 on this one. 60, and then we take that and we need to feed this into, there we go. Okay, so upward still works, and now forward also works. You with me? So what we've done, to recap, is we are blending on our first one. We're interpolating between no change and the offsets that we want, right? Then we're going to add to that interpolation an interpolation between whatever we've done so far plus the offsets that we want for the forward facing direction. And we do need to do the same thing with our translates. So what we can do is the same way we have interpolate for rotation, we can just right click in here and type interpolate, and the pens are nothing right now. What we're going to do is we're going to connect in our original translation. Okay, we're going to connect in our new translation that we want for this particular node, and we are going to drive the weight of this interpolation with the same one that we're doing for the rotation, and then we're going to interpolate here between the cumulative total of all the translations we've done added to the new ones for reaching forward. And in this case, it's this. And then we're going to connect that up to our translations. All right, so now when we do that, we do need to make some adjustments to our translations. For this one, I believe I don't think we want to go, let's see here, let's try 5. Nope, let's try -5. And yeah, it looks like maybe an 8 will make this look good. Better. Okay, so we basically have the interpolation happening between forward and up now, so that this shoulder piece is now basically interpolating between these two regions. How much time do we have? We have 12 minutes. We have one more region we're going to do, so we're basically going to daisy chain on this one more set of interpolations and additions for when our arm is down. Because if we compile, this looks kind of weird with this pauldron just hanging out up here. And because we can do these interpolations, we're going to keep going. So, Hot Sauce has a question. Is it possible to have 2 different morph targets with 1 corrective control rotation? I believe the answer to that is yes. That's what we're doing right now. We're basically interpolating between the two. Okay, so we're going to do one more. So let's take this, let's compile, let's make sure we save just in case we get one of those lovely crashes. We're going to copy paste. This one is going to be when the arm is down. Okay, and we just need to, this is going to be the last of our daisy chains, and then I'll show you all how to connect this into the animation blueprint. Okay, just because of time, I'm going to cheat a little bit and look at my notes. All right, so what we're going to do here with this one is we're going to go 0, and we're going to go -120. So this moves the, it gives us a third region that's pointing down. We're going to reduce our size again to 0.05 on our region, and then our active region scale factor should all be 1. That's cool. Our fall off size is 0.5. That's great. 1. That all looks good. Okay, cool. So now let's take all of this same. Let's take all of this same logic, all of this, and we're going to copy, paste. Okay, these interpolations are going to be driven by our third spherical reader. Okay, and they're going to be a cumulative total of the previous ones. This is really hard to do with the screen so small. Okay, I'll do it like this. So this is going to be that, and then this one is going to be this one. Okay, and then we just need to take these interpolations and connect them up. Now this is probably going to freak out because these values are not correct. Oh, I connected that to scale. That was bad. Don't do that. Okay, so we do need to make some adjustments here because our arm is down by default. You can see this is all whacked out, and the default values we're going to use for our rotations, we're not going to rotate Z at all on this one. We are going to rotate 40 degrees on that, and let's zero out our translations for now. And what we're going to do is change this to just an 8. Okay, so now by default, by adding in this third interpolation, which is within this third region, which is active in the default pose, our character's shoulder is now, the pauldron is actually now pointed down by default. Okay, so if we compile and we save this, when we rotate our arm, we're getting a much better kind of control in all 3 directions, depending on where our stuff goes. Now the question is, does this even look good in game? So how do we get this in game? So I'm going to close down this so I can see y'all's chat now, because we are definitely getting close. Compile and save this. All right, this is where we get to have some fun with why do I have 2 content browsers? With our setup. So currently, so we're working on the live one. What I want to show you is if we go to our mannequin, our Manny prop, this is our prop Manny, the one that we imported, right? What we're going to do is we're going to create a new animation blueprint for this character. So back here in our editor, let's right click and choose create animation blueprint. And we're going to call this, I really just don't like the naming they use by default. This is going to be our prop. I'm going to call this the live post-process Anim BP, for example, so that you all know there's no shenanigans, no smoke and mirrors, okay? And what we're going to do is we're going to connect our control rig in here. Rather than the main, remember, this is not the main animation blueprint. I don't want to even mess with that. This is super easy to add as an after the fact thing using post-process Anim blueprints. So in here, this one's the one piece that's kind of hard to find. I'm going to type in here input pose. So you need to get the input pose as a starting point, and then I'm literally just going to drag here. I can't get the little guy. All right, control rig, type control rig, and choose control rig at the end and connect this in. Now, in order for this to work, obviously we need to set our control rig, which is over here, and we want the live one, control rig live. There we go, compile and save. Now, the cool thing is you'll notice right off the bat, just by putting that in there, hold on. I need to make a note of something. This is, where are you? Okay. Okay, you'll notice that the shoulder pauldron drops down, which is great. So it's already working, but it doesn't work when we play. You'll notice that our shoulder pauldron is not doing that because we need to connect in our post-process and a blueprint. So to do that, what we do is in our skeletal mesh, if you can search for it, but sometimes it's hard to find. So it might be easier just to type post up here. But there is an entry in our skeletal mesh for a post-process and a blueprint. So in here, I'm going to choose the live post-process and a blueprint. Okay, and I'm going to save that. You'll notice that my pauldron updates. Now I want to show you the problem. If I start running around, whoa, my arm's busted. What's going on? It's because our control rig is still set up to drive for testing purposes. Okay, so back here where we're doing this whole driving the upper arm control, we don't want to do that when we're actually playing. This is just for us to test with. So I'm going to disconnect that. I'll leave it right there just in case I decide later, future me wants to come back and edit this stuff. But just by simply making that switch, saving this, let's just save a bunch of these things. All right, cool. Now you'll notice that my arm is there. And the other thing you'll notice is the pauldron is now moving as my character runs. It even adjusts for jumps and things like that. The knife is not as applicable because the knife is kind of on the character's hip, but you could see that it was working. It probably would have been a cooler test to have it on the front of the character's hip so you could see that. But I mean, overall, I feel like once you've done this once, you have this control rig set up. For you to make slight adjustments for any character, the speed of setting up something like this for especially your secondary and NPC characters and things like that, the speed of this implementation compared to dealing with all the exporting and the pose assets and getting all the curves and all those kinds of things, dude, this is awesome. And the minute I figured out you could do the interpolation to do more than one axis, like, I don't know, that seems like a win for me. But with that, we did it. And not only that, we did it with 10 minutes to spare. So what do y'all think? Y'all are pretty quiet. Okay, well, if there are no, I'm happy to hang out, answer any kind of general questions and stuff. No, there is no morph target, hot sauce. It's not a morph target. What it is, okay, so to answer a hot sauce's question, there's a joint, and all we're doing is we are driving the rotations of the joint using a control rig. We don't have to worry about morph targets at all in this case. So the pose asset one, there's another video I did on pose assets that also was not a morph target one, but it used almost the same system as the blend shape stuff to drive the actual final position of the joints. I just think this is faster. That's a really good question, Cesar. Is there a way to transfer some node to avoid doing all the lerp setup? I have not found a weighted sum node, but I don't think it would be very difficult to write one, or to make it so that interpolate could have more than one. So yeah, I didn't see a weighted sum node, but I think you could probably pretty quickly do a weighted interpolate, if you will. Morph targets are a different workflow. Morph targets will help for bicep flex and shoulder correct. Yes, so morph targets are set up. Well, I mean, there's lots of uses for them, but you can use them for exactly what you said. Doing it is another tool in the arsenal of tools that you have available to you to help with corrective shapes. So if you have things like biceps and probably not twist, but I'm thinking of like mostly volume preservation type stuff and or facial stuff, then yes, morph targets are great. All right. Well, as always, 100% shout out, thank you to everybody on Patreon who helps support the channel. I very much appreciate that. Can't thank you all enough. Everybody's in Discord. Everybody's helping each other out. Such a great community that we're building. If you don't know what's going on with all that stuff, check out the links in the video description down below. As always, I'll go back and I'll update the chapter sections of this so that you can go back and reference this video and quickly find the key moments and parts. And if you're watching this after the fact, all comments, feedback, welcome. All of our videos come from community requests and Patreon. So if you all have ideas for topics, or there's pieces of Unreal that are still particularly confusing, that's kind of the whole point, for us to try to help shed light on those areas. And I'm super excited to be digging into a bunch of the new stuff that comes out with 5.4 preview today. For example, I know they did a bunch of skinning updates. We'll go back and recap based on what we had said during our pets series and so on. So I hope you all have an awesome weekend, and I'll catch you on the next live stream. Take it easy.